this lesson will help us understand intuitively what a derivative is. And so let's look at this example. Here's a cubic function, and I'm using a program called Autograph. And before we try to understand what a derivative is, we're going to try to understand what a tangent line is. So here's a point, and as I'm dragging this point, then the autograph we're gonna keep drawing the tangent line to the graph as I keep moving my point around the curve here. So one way to understand the tangent line is think about this as a roller coaster ride. If you're on a roller coaster ride and you're sitting right here at this point, then your line of sight would be the blue line, and your line of sight would be the tangent line. And so as you go and then you're looking up, and eventually as you get to the top, then your line of sight levels out and faces down as you are going down on the roller coaster. Another way to think about this, if you like X-Men, is that if you are Cyclops and you are on the roller coaster and you take off your glasses, then your ray of vision would be the blue ray as you're riding this roller coaster. So a lot of damage going on here as you're riding the roller coaster with your sunglasses out, assuming you're a Cyclops. Okay, and so if you understand the idea of a tangent line, then the derivative is simply the slope of the tangent line. And so that's it. That's a pretty simple definition. At any given point, there is a tangent line, and the slope of that tangent line, which is a number, is the derivative. Okay, now let's look at another function. I'm going to look at the function y is x squared, and there's the graph. Now I'm going to put a point on this graph and then draw a tangent line to it. There it is. Now the question is, what does the derivative tell us about the function? Well, what does the slope of a line tell us about the line? The slope of a line tells us how fast the line is changing with respect to the y and x axis. So for example, at this point, the tangent line has slope. Here's the information about the tangent line. The tangent line has slope 2 at this point. When x is 1, y is 1, the tangent line has slope 2. And what that means is that if you are moving on the x-axis 1 unit, then you move up 2 units. So you move over 1, up by 2. Or if you move over by 0.5, then you're moving up by 1. So the tangent line, the slope of the tangent line tell you how fast the y value is changing in relation to the x values. So in the same way, the derivative tells you how fast the curve is changing. Let me illustrate that by zooming in. So let's see. So suppose I zoom in to this point of the graph. And notice as I zoom in, the curve becomes more and more straight. In fact, as you zoom in closer and closer, it looks like a line. And what is the slope of this line? Well, it looks like it's almost 2. And you remember that the slope of the tangent line also has slope 2. So let me zoom back out again. So to recap, the tangent line will allow us to see how fast the curve is changing. So for example, at this point, the tangent line has slope 2, so that means that the curve is curving approximately at a rate of 2. In other words, for every 1 unit increase in the x-axis, then the curve is curving approximately 2 units on the y-axis. And so let me illustrate this with another graph. Notice that as I move this curve down, then my tangent line has smaller and smaller slope. That means that my curve is changing slower and slower. Eventually when I get to 0, my tangent line is horizontal. That means it has no slope, and the parabola, the curve at that point, is not changing at all, because it's the point where the graph had decreased to the lowest point and about to increase. And as I move back, I notice that the tangent line has negative slope, and that indicates that the curve is decreasing at that rate. Okay, now we're ready for a more rigorous definition of the derivative. So let me move this over. Now suppose that I have a point which I call P, and let's P be at 1, and a point which I call Q. And what if I draw a line connecting those 2 points, P and Q? Notice this is called the secant line, and notice if I move the point Q away, then my secant line is changing, and if I move it towards the point P, then my secant line is changing in the other direction. And notice as P is approaching Q, then my tangent line is approaching slowly my tangent line. And so in other words, in the terminology of last week's lesson on limits, the limit as Q approaches P will give the limit as the secant line approaching the tangent line. And so we see that from this simulation here. And as we get closer and closer, the secant line is approaching the tangent line. Okay, now we're gonna put some coordinates, some names onto these coordinates and try to understand this another way. Again, we call this point P, and its function, this function is f of x, and this point P has x coordinate, therefore has y coordinate f of x. And Q will be this point right here. We're going to let h be the distance between the x distance between P and Q. So if h is the distance between the x coordinate of P and the x coordinate of Q, then x plus h will give the x coordinate of Q. And notice again, just like before, as Q is approaching P, then h is going to 0. Okay, so let's do a recap. Okay, this is the tangent line to the function at P. And again, we want to know how to find the slope of that tangent line. The slope of this tangent line is called the derivative. And so we talked about the fact that as Q is approaching P, then the slope of the secant line will be approaching the slope of the tangent line. And so for us to find the slope of the tangent line, which is the derivative, we need to find the limit of the slope of the secant line. So let's look at some formula here. So what is the slope of the secant line? The slope is found by rise over run. So the change in y, which is the right, is the y value of Q minus the y value of P. So that's f of x plus h minus f of x. And the run is the change in x, which is h. And so the slope of the secant line is f of x plus h minus f of x all over h. And we want to find the limit of this expression, because the limit of the secant lines is the tangent line. So this is the rigorous definition of the derivative. It is the limit of the slope of the secant line, and that limit, if it exists, is called the derivative. And the derivative is a number that represents the slope of the tangent line, and that number represents how fast the curve is changing at that instant. And we will take this definition, and in our next lesson we will talk about how to use this to compute derivatives.